Hello, this is Ms. Cliffner with your video lesson on more ratio tables. It is 5.2 in Big Ideas Math, and we're going to go ahead and start with a warm-up that looks like this. It is actually page 104 in your record and practice journal, so if you have that handy, you should just take that out and do the first 6 problems. Go ahead and pause the video. I'm going to go to the next screen, and I'm going to show you how you fill out the ratio tables. So remember, when I have a missing number, I need to swoop toward that missing number in the ratio table and then look for a pattern of multiplication or division. So I go to the information that I have, and I have for every 3 kids, there's 1 adult, and I need to find out how many kids per 3 adults. So I'm going to do the 1 times 3 is 3, and then I would multiply the top number by 3. So if you have 3 kids per 1 adult, then you can have 9 kids per 3 adults. All right, basketballs compared to footballs. The missing numbers in basketball, I swoop toward the missing number. 10 times 2 is 20. 5 times 2 is 10. So for every 5 basketball, there's 10 footballs, which means I'm going to have 10 basketballs compared to 20 footballs. All right, apples and oranges. We're missing the number of oranges, so I need to swoop toward the oranges on the top and the bottom. I'm looking at the pattern on the top. 4 times 4 is 16, and 5 times 4 is 20. Now this one is the trick. It starts to get a little trickier here because I'm swooping actually to the left because the missing number is there and the information that I have is on the right. The number is getting smaller, which means it's going to be a division pattern, right? So what do I divide 27 by to get 9? Well, it's a divide by 3 pattern. So I also need to divide this one by 3. 30 divided by 3 is 10. All right, next. I've got a ratio of regular to decaf. I prefer 1/3 instead of 2/3, so I do 1/3 regular. Here we go. I'm swooping toward the missing number. 3 times 4 is 12. 2 times 4 is 8. So if you're going to make 2 parts regular to 3 parts decaf, if you're going to multiply it by 4, you would have 8 parts to 12 parts. Now let's find how much decaf you would need to add to go from 8 to 32. Now if I wanted to, I could go all the way from 2 and do a big leap up to 32 because 2 times 16, but I decided I want to do just one. I'm going to do little stepping stones, 1 step at a time. I multiply by 4, so I multiply this number by 4 and I get 48. Okay, so now we're comparing ratio of bikes to scooters. Notice again, I'm always swooping toward the box. So if my number gets smaller, going to 5 from 5 to 1, I know I need to divide by 5. So I'm going to divide 15 by 5 and I get 3. Now when I go in the other direction, again, there's my missing number. I'm going toward the missing number. This is a times 5 pattern, times 5, and I get 25. Okay, the more you practice ratio tables, the easier it gets. Okay, so here's an example of a recipe that can be made in different servings, right? So I've got servings. I have the ingredients for eggs and milk. I have for 4 servings, 2, 6, 3, 5, and 9. And here is my question. What I want to do is I have 14 friends coming over for brunch. How can I use the table to make scrambled eggs for 15 people? So you know how I said you don't add really with a ratio table, right? To go from 4 to 2, I divided by 2, but it makes sense that if you're looking at the total number of servings, you could add those together, right? So I'm looking for all the different ways. Oops, even though there's 4 friends coming over, some people eat a lot, so I'm going to make scrambled eggs for 15 people. So I'm trying to find some combinations that are going to add up to 15. Right? So I could do this. Let's see. I could take recipe A for 4 and include C and then include E, right? Because 4 plus 6 is 10 plus 5. So recipe A plus C plus E. And if I did that, it says how many eggs do I need? So now I'm going to go through with a different color and circle the eggs. So I need eggs would be 8 plus 12 plus 10, there's 20 plus 10 equals 30. And then the milk, let's do in green, milk. I need a half a cup. Fractions, 3/4 and 5/8. Okay, so here we go. 1/2 plus 3/4 plus 5/8. All right, I know the common multiple with 2 and 4 and 8 is 8. So 5/8 already has an 8 on the bottom. I'm going to take 3/4 and I'm going to multiply by 2 over 2 and I get 6/8. And then I'm going to take the 1/2 and multiply by 4 over 4 and I get 4/8. So what I'm adding now, I'm going to replace the 1/2 with 4/8. And I'm going to replace the 3/4 with 6/8. So I've got all the same sizes. So now I can add the 4 plus 6 is 10 plus 5 is 15. So I have 15/8 of cups of milk, and 8 goes into 15. Let's see, almost 2 times, but not quite. It goes in 1 time, and I have 7 left over. So I need 1 and 7/8. Oops, not an M. 1 and 7/8 cups of milk. 30 eggs and 1 and 7/8 cups of milk. Okay, so now this is what we've been learning about, right? We've been learning that equivalent ratios simplify to the same equal fraction. We've been looking for multiplication and division patterns. And then today's notes, we're starting with how do we create part to whole ratio tables. Okay, so here's what we're going to fill in. We create a ratio table with part to part. So fill in the word part, fill in the word part. Then we're going to add another row for the total. Fill in that word. Then we're going to know that the total row, it could be the sum or the difference, depending on what the problem is. I'm going to move that. And then the last thing is we use multiplication and or division. So fill in multiplication or division to find the relationship between the ratios. Okay, so let's get into some examples. There's 2 whole numbers that when I say satisfy the following conditions, you have to look at, it's like looking at clues, right? So it says, if I take A plus B, it adds up to 30. So what I want to do is I want to take A plus B, and this is going to be my total. So if I take those 2 numbers, they add up to 30. So here's what I know. I know that I have to think about first of where I put my numbers. And so what I want to do is I want to say, I'm going to add this to the table. This is my, let me undo that. This is my ratio. So I'm given a ratio. And remember when you're given a ratio, that's a part-to-part ratio. That doesn't actually tell you how many numbers there are. So I label this as ratio, and I'm going to label this as actual. So the idea is, if the ratio is 2 to 3, it doesn't mean the number A is 2 and the number B is 3, right? Because it says at that first clue that A plus B is 30. Now I could do a whole bunch of guessing and checking, but when I have a table, I don't need to do that. So if the ratio from A to B is 2 to 3, I write it like this. Now the total here is actually A plus B. So let's go ahead and erase that. Instead of total, I'm giving myself some better clues. I'm going to write A plus B equals. Now in the ratio, my A plus B is 5. So I'm picturing those tape diagrams and how I drew 2 boxes for A and 3 boxes for B. And we look at a total of 5 boxes. Now I just don't have a picture. It's all in a table. And then what did I tell you that A and B add up to? They add up to 30. So this is my actual numbers, right? This is the ratio numbers and this is the actual numbers. So then I go, well, the only place where I actually have the 2 numbers filled in is that last row. So I'm going to write this real small. Instead of swooping, I have an arrow. What do I multiply 5 by to get 30? It's a times 6. So I multiply every other number in that column times 6. So 2 times 6 is 12, 3 times 6 is 18, and now I'm checking my math when I get here. Right, this is my little check. Is 12 plus 18 equal to 30? Yes, it is. So I know I got the right value for 12 and I got the right value for, for A and the right value for B. Okay, so that is one example. Okay, so now I have an OYO, so I want you to try this one. It's another adding one. I'm going to move me. Okay, and move this over. Okay, make this a little bit smaller. There we go. All right, so try this one on your own. It's very similar to the other problem where you're adding two numbers and they equal 75 altogether. So you're going to want to do this A and this B, and this would be A plus B. Once you've solved the problem, go ahead and unpause the video. All right, so here we go. The ratio is 8 to 7. That totals 15. And when I add those two numbers, I get to 75. And then I know that if I multiply 15 times 5, I get 75. So this is also times 5, and this is times 5. So I get 40 and 35. And yes, they add up to 75. So the two missing numbers were 40 and 35. Okay, now we're going to do an example where we're subtracting. So same idea. There's my A, there's my B. Now this time my total is A minus B, so I go ahead and put A minus B. And then remember, this is the ratio, and this is the actual numbers. So the ratio is 11 to 5, and the actual number when I subtract them is 18. So 11 minus 5 is 6. So what would I multiply 6 by to get 18? It's times 3, times 3, times 3. I get 33 and 15. And then I check, is 33 minus 15 18? Yes, it is. So A would be 33 and B would be 15. Okay, now I have an OYO where you're going to try to solve these just like we did the other one. Find the value of A and B. If A minus B would be equal to 45 and the ratio is 9 to 4. 9, 4. This is the ratio. This is the actual. I put, let's see. Oh, I don't know though. I'm trying to guess those numbers. I put a 45. And then I do 9 minus 4 is 5. This is a times 9 pattern. Times 9, times 9. 9 times 9 is 81. 4 times 9 is 36. And I can get a calculator and verify 81 minus 36 is 45. So the numbers that I started with were 81 and 36. Okay, last one. Last example, and then an OYO. Okay, so here we go. 7 out of every 8 students surveyed owns a bike. The difference, subtracting, between the number of students who own a bike and those who do not is 72. How many students were surveyed? That means I'm trying to figure out how many there were altogether, right? So let's see what information I can fill into a table and see what I get. So I'm thinking what I need to do is, let's see. I want to say there's a number of students who have a bike. It's kind of like the dog, no dog one that we did. And then I have a no bike, right? So there is a bike and there's a no bike. Now what I can do is I can add, you can see I gave you 4 rows. I can do a total, and then this is where I can do the difference, because it said the difference between the number of students who own a bike and those who do not is 72. So the difference down here, so remember this is my ratio, and then this is my actual numbers. Okay, so the difference is 72 right here. And then let's see, the other information that I have is 7 out of every 8 students surveyed own a bike. So 7 have a bike, and then ding, 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 I hope you notice that the out of, right, that is the total number of students that they surveyed. So that means this has to be 8, which means the no bike is a 1. Okay, now I'm still trying to find that difference column. I want to make sure I'm subtracting the right numbers, right? The difference between the number of students who own a bike and those who do not. So this is own a bike. This is those who do not. So I'm doing 7 minus 1. 7 minus 1 is 6. Now that I have everything filled into my table, I can figure out what I need to multiply 6 by to get 72. And hopefully you're thinking it's 12. So this is a times 12. So all of the numbers get multiplied by 12. There's a times 12. And there is a times 12. Remember the asterisk means times. 7 times 12, let's see, 84. This would be 12. This would be 96. So it said how many students were surveyed. Well, there wasn't just 8 students surveyed, right? That was the ratio. So total number of students surveyed is, ding ding, the total is 92. So they surveyed 92 students. Okay, that's a tricky one. And here is an OYO that is also a tricky one. The ratio of 3 numbers is 4 to 3 to 1. The sum of the numbers is 64, and you're trying to find what the biggest of those 3 numbers are. I'm going to start to fill out the table. This is going to be the actual, like I've been doing. This is going to be the, let's see, ratio, and then I'm going to label it like this. This is going to be the greatest. This is going to be the middle. This is going to be the least. And this is going to be the sum. Okay, pause the video. See if you can solve this problem. So I'm going to put in 4 is the biggest, right? Not that 4 is the biggest, but the ratio of the greatest number is going to be 4 to 3 to 1. And if I'm thinking about a tape diagram with all of those boxes, I would have 4 plus 3 plus 1 equals 8. And then it tells me that the actual sum is 64. So I know that's 64. And then I can go ahead and say, what do I multiply 8 by? It's times 8. So all of these are times 8, times 8, and times 8. So 8 times 4 is 32, 24, and 8. So if I add 32 plus 24 plus 8, I get 14, carry the 1. Yep, it adds up to 64. Ooh, sorry. So the question says, what is the greatest, right? What's the largest of those numbers? So the largest of those numbers is 32. Okay, good luck with the homework.